Hi guys, in this lecture we'll be discussing about a problem on a venturimeter. So previously we have discussed about venturimeter, so how does it actually work, and with the help of venturimeter we can able to find the coefficient of discharge or discharge through the pipes. So the problem statement is given: a 30 cm cross 15 cm venturimeter is provided in a vertical pipeline carrying an oil of specific gravity 0.9, the flow being upwards. So the oil that flows in upward direction in a pipe, in a vertical pipe, we have a venturimeter which is being fixed. So the difference in elevation of a throat section and entrance section of a venturi is 30 cm. So elevation difference is given at the entrance, it is 0. So from here to at the throat the difference is 30 cm. The differential YouTube manometer shows a gauge deflection of 25 cm. There is a deflection value of 25 cm between the mercury levels in the two limbs of a YouTube manometer. So this shows a reading of 25, which is due to this pressure difference. So now we need to calculate the discharge of an oil through the pipe. So what is the amount of fluid that flows through the pipe per second? The pressure difference between the entrance section and the throat section. So we're going to consider the coefficient of discharge, which is equal to 0.98. So as we already discussed in venturimeter, that the efficiency of venturi is much greater. So we're going to take the coefficient value of 0.9, and specific gravity of mercury is a constant, which is equal to 13.6. So now the given values of diameter at inlet 30 cm, which means that the pipe is of diameter 30 cm. So area of pipe will be equal to pi by 4 30 square, so 706.85 cm square. Diameter of throat, which is 15 cm. So you can find the diameter of throat, which is equal, means area of throat, which is equal to 176.7 cm square. So let section 1 represent the inlet and section 2 represents the throat. Then Z2 minus Z1, which is equal to 30 cm, which means that, so this is section 1 and this is section 2. So the difference in elevation, Z is actually the datum energy, which we have already discussed in Bernoulli's derivation of a Bernoulli's equation. So Z1 and Z2 is a potential head, or we call it as a datum head. Datum is a height. So the elevation difference between them is 30 cm. So Z1 minus Z2 is 30 cm. Z2 minus Z1 is 30 cm. Right, sorry. So 30 minus 0 is equal to 30. So 30 cm. Specific gravity of oil 0.9, specific gravity of mercury 13.6. Reading of differential manometer, which is the deflection in the source, 25 cm. So the differential head H is given by H will be equal to P1 by rho g plus Z1 minus P2 by rho g plus Z2. So this we have already discussed in Bernoulli's equation. So from Bernoulli's equation, if you need to derive the expression to find the coefficient of discharge in a venturimeter, so you can able to attain this. So it's a halfway of derivation of venturimeter. So you can check through the notes. So as you know, H will be equal to SH by S0 minus 1 into X for heavier liquid in a manometer compared to the liquid that flows in a pipe. So here the fluid flows in a pipe having a specific gravity of 0.9. The specific gravity of mercury is in a manometer 13.6. So we apply this formula, which we already discussed in venturimeter. The two different scenarios. So X is 25 cm. So here it is 13.6 by 0.9 minus 1. So we can able to find 352.77 cm of an oil, which is a head. So discharge through the pipe will be equal to Q, which is equal to CD into A1 A2 by square root of A1 square minus A2 square into square root of 2GH. This is a formula to find the discharge by using venturimeter. So A1 A2 we have already calculated. So CD is the coefficient of discharge. So if we put together, so H we have already calculated here. So if we put together, we can able to find the discharge through the pipe, which is 148.79 liters per second. So we have some simplification. So everything is in terms of centimeters. Okay, so if you form them, I'm able to get in terms of centimeter square per second. So make sure the value of G, which is 9.81 meter per second, right? So make sure that you do not substitute 9.81 meter per second. So we need to substitute in terms of centimeter per second. So centimeter square per second, meter square per second. So acceleration will be is meter square per second. So centimeter square per second, so into 100. So that's why 9.81 becomes 981. So make sure you do not, or if you want to make it in terms of meter square, so convert everything in terms of meters. First, then try to substitute it. So the value comes out to be 148,790.5 centimeter cube per second. So to convert it to liters, so we're going to divide them by 1000. So 1 meter cube will be equal to 1000 liters. That's the standard. Okay, so from that we can restructure this values. So the next we're going to find the pressure difference between the entrance section and the cross section. The pressure difference between entry and flux. So from the same formula we have already known the value of H, which is 35.3, 352.77. So P1 by rho G minus P2 by rho G plus Z1 minus Z2 will be equal to 352.77. So already we know the value of Z2 minus Z1, which is equal to 30 centimeters. So we take that Z2 minus Z1, so we have to change the symbol, which is equal to minus. Okay, so minus 30. So take to the other side, plus 30, P1 minus P2, P1 by rho G minus P2 by rho G will be equal to 382.77 centimeter of oil. Convert them into meter. So P1 minus P2 is equal to 3.82 into rho G. So rho is the density, G is the acceleration due to gravity. So here we know that specific gravity of oil is given 0.9. So if we need to know the density of an oil, so from the properties of fluids, specific gravity will be equal to density of fluid by density of standard fluid. So for density of fluid will be equal to specific gravity into density of standard fluid. So 0.9 into 1000, so 1000 is the density of water which we are investigating as a standard fluid. So it will be equal to 900 milligram per meter cube. So that's a mistake. So P1 minus P2 will be equal to 3.827 into 900 into 9.81 is the acceleration due to gravity, Newton per meter square. So if we put together, we can be able to get the values. So which will be in terms of centimeter square. So this value will be in terms of meter square. If we divide by 10 power 4, we can be able to get in terms of centimeter square. Right? So okay guys. So this will be 3.3795 Newton per centimeter square will be the pressure difference between section 1 and section 2. So this amount of pressure that is been reduced from section 1 to section 2. So due to this reduction in pressure, there have been some increase in velocity also. So this is how the burner is actually states. So thank you for watching.